Okay, so without actually looking too much at this bit that I've got written down here, I'm going to just talk through what the question says at the top, and we probably have a bit of an idea of what's going to be happening here. But the first thing it's asked for us to do is to sketch the curve with this equation, which is x minus 1, x minus 2. And we know for this particular curve, we know a few things about that curve. What can you tell me about that curve, x minus 1, x minus 2 in that factorized form? What do you know about that curve? The roots, tell me the roots. And 0. So there's a root at 0, 1, and 2. What type of curve is it? It's a cubic. So actually, I know we've got the sketch here, but we've got 0, 1, and 2, and it's a positive cubic. So it looks like this, okay? And the whole thing, just to save us a little bit of time, it expands to this thing that we've got here. I'm going to calculate, I'm going to integrate between 0 and 2. So I'm going to integrate between here and find out what happens. And you can just watch what I do here. You don't need to write this bit down. You can just watch this. So I'm going to try and integrate between 0 and 2. Instead of integrating this bracketed version, because you know you can't integrate when they look like that, it has to be a polynomial, I'm going to integrate x cubed minus 3x squared plus 2x. And all of that is between 0 and 2. So, Arisa, what does the x cubed integrate to? A quarter x to the 4. And Amina, what does minus 3x squared integrate to? Good, minus x cubed. And Mabel, what does 2x integrate to? Good, x to the power of 2. And our limits there are 0 and 2. So when I substitute 2 into these bits, I'm going to have a quarter times 2 to the power of 4. What is a quarter times 2 to the power of 4? Is it? It is. And 2 cubed is, and 2 squared is 4. And I'm going to be subtracting from that 0 to the power of 4, 0 cubed, 0 squared, 0. So what does this all equal? 0. What? Why? Well, that's so odd that we had this sketch and we said that the area between here and here, this area and this area, is 0. We can see with our eyes that it has not got 0. This is because of negative areas, okay? This is because when our calculation that we've done here is trying to find out the area underneath the curve, it doesn't realize that some of the curve has gone underneath the axis, okay? So let's just have a quick look at what I've written here. Do you remember last lesson we talked about like the rectangles, and we said it was about finding the area of the rectangle? So I've said, as we said before, this explains the dx in the, actually no, I should read this bit first, sorry, up here. So when we do the integral of f of x dx, it's just the sum of the areas of infinitely thin rectangles where the current y value, i.e. the f of x bit, is each height, and the widths are dx, i.e. the area of each little rectangle is the height times the width. That's what we talked about at the end of each lesson, and that S symbol at the beginning actually means the sum of all of those rectangles added together. So just this was the note around this. When we said this explains the dx in the f of x dx, which effectively means the sum of the areas of strips, each of area f of x times dx. So the dx is not just part of the notation, it's actually behaving as a physical quantity, i.e. the length of the rectangle. I'm just wanting to reinforce some of those ideas we spoke about last lesson. The problem is, when f of x is negative in this section that we have here, then f of x times dx is negative as well, because the value of f of x is negative. So as far as our method is thinking here, they're just saying the area of this rectangle is minus something multiplied by dx, which is obviously just going to be a minus number there. So the result is that the positive area from 0 to 1, whatever this area was here, is cancelled out by the negative area from 1 to 2, which gives us an overall area of 0. Because this area happens to be exactly equal to this area. This one we consider as positive. This one, when you calculate it, will come out as negative. So if you are trying to find the areas, you have to be careful if something dips below the axis. If it dips below the axis, you will get a negative answer. But it doesn't make sense for area to have a negative in front of it because it measures space. It's not measuring a direction. So how do we actually calculate this? Well, the way that we do this is we will work out the area between 0 and 1. We will work out the area between 1 and 2. And between 1 and 2, we will get a negative answer. So we will just make it become positive. We will just take the magnitude of it. You know what the word magnitude means? So we're just going to take the magnitude from it. So the way we do this is we split the integral into two separate pieces. And take the magnitude of any negative areas. This idea is very important when we come to our next topic in mechanics, where we find areas underneath curves to find distances. Because if you find the area underneath a curve and the curve happens to have gone below the axis, you're going to get a negative value there. So you might have to do it in this method of breaking it down into separate pieces. So what I'm actually going to do is I'll work out this one by integrating between 0 and 1. And then I'll work out this one by integrating between 1 and 2. Yes? I could. So you're right. Because I know a special property about this particular graph, Shahan just said, couldn't I work out the area of 1 and then just double it? He's absolutely right because of this graph, because we knew that the whole thing was 0, so they had to be equal. But imagine it was a graph that looked like this. You would have to do them separately. But I'm just trying to finish off the first example that we did do. But you're totally right. We're expecting this area to be the same as this area, but this one is going to be negative. Just in case you have one that's a weird shape, you have to do them separately. So I'm going to be a bit extra, and I'm going to do it the long way. So we're going to integrate between 0 and 1. What was it before? It was x squared or x cubed plus 2x dx. And we actually did all of that integration. So just to save us a bit of time, we get a quarter x to the 4 minus x cubed plus x squared. And that's just between 0 and 1. We don't have to worry about substituting in the 0 because that's all just going to disappear. So we just get a quarter minus 1 plus 1. So it's just a quarter. The area of this is just a quarter. And then we're going to do the same thing between, this time though, 1 and 2. We should know what the answer is going to be. What is the answer going to be? Minus a quarter. We know it's going to be minus a quarter just because we've investigated the start of this problem. So I'll put 2 in. That's a quarter times 2 to the 4 minus 2 cubed plus 2 squared. Minus, well, I know when I substituted 1 in, I got a quarter, so I can just do that. So it's 4 minus 8 plus 4 minus a quarter. So we get minus a quarter. So the area is a quarter for this bit. It's come out as a negative because any part of the graph that goes beneath the axis, when you calculate it, it will be negative. It kind of makes sense. Anything below the axis is negative, so the area is negative too. So the total area bound between the curve and the x-axis is equal to a half, because a quarter plus a quarter is 2 quarters or a half. And the wording of that says the area bound between the curve and the x-axis. So you get that kind of strange shading of above and shading of below. So don't be that person that gets tricked and just thinks, well, I'm going to integrate between 0 and 2. Be the person who integrates between 0 and 1 and between 1 and 2. Obviously, it's more work, but this is why it will be worth more marks in the exam, because you're having to do more for it. So you'll see on the top of your next page, there's an exam question that I'd like us all to do together at the same time. That looks like this. And Shahan, you can see now how you can't just double them because they obviously look different to each other. So I'm going to start doing this myself slowly on the board if you're not sure, so you can watch what I'm doing, but you should be able to now do this by yourself, okay? So I started part A for you. I'll go on to part B in a little bit. Yes?
Could you do 4-0 as well, just to get you positive family?
No, because if you do 4-0, it's actually going to be doing between 0 and 4, and it's going to be it will be working out the area of that and the area of that. So you have to follow exactly what the limits are that they have, okay? You can't manipulate it to get what you want. think you just need to type that into your calculator carefully. I don't think it should be minus 8 over 3. Did you forget to, did you times it by 2/3? Let's have a look. So you've got, because at the beginning it says, it says a half on your calculator, but it should say a quarter. So if you change that, you should come up with that one as well. And here, that's minus, so it's going to be minus all of that, so it should be a minus minus, so it becomes a plus. Okay? Okay. Don't worry if you haven't quite finished yet. Yeah, but remember you can't have a negative area. So we treat it as 20 over 3, yeah? Okay, so if you haven't quite finished, not to worry, but the first part you just have to pick out the coordinates because it's already factorized. Potentially you may need to factorize it yourself. Okay, you could have seen this thing and you would need to know how to factorize that and find out where it crosses the axes. Or you could put it into your equation solver, whatever, right? All you then need to do is between -4 and 0. You cannot change the limits. You have to do the limits that are there in the diagram. And that came out as 128 over 3. What am I pleased about 128 over 3 there? It's positive. I expected it to be positive because it was above the curve. I'm anticipating when I do it between 0 and 2, I'm anticipating to get a negative area because it's below the curve. And I do, I get -20 over 3. So the area that I'm actually treating it as is 20 over 3. So the total area, you add the magnitudes, the sizes of them together, and you get 148 over 3. I'd like it if anybody could think, if you put this into your calculator between -4 and 2, I'd like to know what anybody thinks the result would be if you just put it into your calculator between -4 and 2. Yes, why would it be 108 over 3? Yeah, because what the calculator would actually be doing is it would be doing that chunk, add that chunk. So on that one, it would be adding on a negative. So it wouldn't give you the true area. It would give you that area plus the negative area. So it would give you a kind of an amalgamation of those two. No, so if you wanted to check the answer, you would have to integrate it between -4 and 0, and you would get that. You'd integrate it between 0 and 2, and you would get -20 over 3. There is nothing you can do on your calculator that will give you 148 over 3 unless you break it down and make sure you add those two pieces together. Okay? So what I'm going to ask for us to do is to do a couple of questions from exercise 13F, and then we're going to come back together in just a second, okay? So the question